So the goal of this panel is to kind of talk about what it's really like to work in ZK. And I wanted to have guests on who are kind of at different points in their career. Like Brendan, I know you've been in the space for a really long time. Nico, we were trying to figure out in the jargon decoder how long you've been in the space. Anyway.
I got my numbers right.
You got them right finally? Okay,
yeah.
good. But yeah, so I think what I wanted to do was to start with an intro to each of you and a bit of like your story of what first got you interested. What was the thing that you saw or read that made you excited about ZK? Nico, why don't you start?
Yeah. So I was, sorry, just an intro in general to start with? Or...
Well, yeah, who you are and then what's the first thing that got you excited?
Nico, maybe you remember me from the first session of this ZK hack. I do research in applied cryptography at Geometry Research, and I have the honor of being sometimes a guest co-host on the ZK podcast. So what got me into ZK, it came from like really a privacy angle. I was really interested in privacy in general, and I had a technical background. So combining privacy and technology sort of took me immediately to cryptography. And from there, learning about cryptography, I eventually learned about zero-knowledge proofs.
And why were you interested in it at that moment? Like, so you learned about it, but what was it that made you want to jump in?
Yeah. The privacy or
the
zero-knowledge cryptography?
Yeah,
ZK.
the ZK part.
It is kind of the most effective way to get privacy, or to keep doing things we want to be doing without revealing necessarily compromising information about us, or even just private information, even if it's not compromising, right? So encryption is great because you get to hide stuff, but if I want to convince someone that I am allowed to vote, I need ZK, and that's sort of the only solution, the only technical solution that we have there. The nice thing about it is it feels magical, right? You don't have any trusted party. You don't need to reveal anything. Like how is this possible? And I think that magic, and also sort of the aesthetics of the mathematics sort of got me into it.
Cool. Brendan, what about you? I actually don't know this at all. Like your origin story for ZK. And when was it? I wonder if it was before me.
Yeah, it's not that interesting. I'm Brendan. I work on ZK stuff at Polygon. And I guess for me, like I studied math in undergrad, and I'm going to date myself, but I was an undergrad when the Snowden leaks came out. And so I really was sort of interested in cryptography for encryption and privacy. And after school, I was working at this like very, very boring startup, and I was living in right near Palo Alto. And I was just like dying for some way to like do something that was more mathematically interesting. And I wandered into this talk that Vitalik was giving on plasma. And in the talk and in the paper, he sort of mentions offhand, we have this like game theoretic construction, but in the future, you'll be able to do all of this with like snarks or zero-knowledge proofs. And that just like immediately caught my eye. And I had no idea what zero-knowledge proofs were. But that was sort of my on-ramp to like knowing more and to like learning about Zcash and other ZK projects. And so I guess in 2018, I went to ZKon Zero at Daniel Lubarov, and we ended up co-founding a project called Mir that was trying to do some privacy and scalability stuff as an L1, and we were acquired by Polygon in late 2021. And since then, I've unfortunately, I like to say that I've gotten a lot dumber because I don't get to work directly on zero knowledge stuff as much. But the team has been working on things like Plunky 2 and Starkey and Plunky 3, and so it's been fun to kind of be around that. And
Brendan, one of the questions I had here was about starting your own project. So it sounds like ZK and starting your own project happened at the same time. So you hadn't been doing it. You were more like hobby interested, and then you found a co-founder. But what's it like? Like, what was it like at the time to start a ZK project yourself?
Yeah, I mean, this was
Did
like
people understand it, or?
No. So this was like late 2018 into 2019, and to be honest, it was really intimidating. Like that was like 5.5 years ago, and at the time, it felt like there were so many people in the space that had been there for so much longer than me. And so like the Zcash crew and like Mina had gotten started then. And so it was really intimidating. And I think that there was a lot of skepticism about the tech and the pace of development and sort of where it was. I think it's really hard to like locate where you are on like a parabolic curve that where the technology is accelerating really rapidly. And so I think that was a challenging thing for us.
Did you think you were too late?
No, we thought that we were too early. So
you thought you were too early?
Yeah, because it's like when you're, especially like the market cycle that we raised in, it was really, really difficult to raise money. And so we were undercapitalized, like kind of from the beginning. And when you're doing a project that's like in a startup form, it's actually a really painful thing to like not immediately work on building the product. And to be in this like state of uncertainty where you don't know if the tech will advance fast enough for you to ever make something that's practical or that works. Wow. And so you have to like be willing to like take on a lot more risk and R&D risk to like push the development of the technology yourself. And so I think that was like often a really uncomfortable position because we had to tell our investors like, yeah, like we've been really focused on accelerating zero knowledge proofs. Like still no blockchain for you to launch a token on. So yeah, so I think that was like a tricky thing.
I don't know if I've said this on the show ever, but did I tell you this funny thing I learned when I looked up the trademark for zero knowledge? No. There was a company in the late 90s called Zero Knowledge. And it was based in Montreal, where I'm from. Did I tell you this? And the office was across the street from this bar I used to go to a lot of times. And I think that like somehow I may have met these people. This is like this theory that I have. But like, I think they were too early. Like, I think they, like, I could see that the company existed and then it didn't exist any longer. So yeah, I could imagine you would have felt it was too early, but I think you were okay in terms of timing.
Yeah, our timing was good, but I mean, if you imagine, like, I think the margins were very thin. Like if you think about how quickly the technology has developed, it's been like maybe 100x improvement in speed. Like for what we want to do with ZKVMs and with scaling Ethereum, it's been probably, I would say, like 100x improvement in 4 years or 5 years. And like if the industry had been like a little bit earlier, we would be looking at ZKVMs where the cost to prove a transaction is like $1 or $2, and latency is like on the order of hours or days, and that's not really like a workable configuration for what we want to do. And so I do think that the timing was good, but like the margins were very thin.
Okay. What about Oh, wait, I think we might have our other guest. Perfect timing. Great. Yay.
Hey.
Ryan.
Sorry about that.
I'm so glad you made it.
Yeah, me too. Yeah.
Sorry. I was trying to help you a little bit there, but we started the panel.
No
I
worries.
don't know if you actually heard the initial question, but I'm going to sort of throw it your way and welcome, Brian. So in this, we're talking about sort of the origin story of everyone. What got you excited? And in your case, when did you decide, like, had you been excited for a while and then you decided to kick off a company? Had you worked on it before? Yeah, just your origin story in ZK.
Yeah, my co-founder Jeremy is definitely the person who ZK told me in the first place, and that was really like probably 8 months before we actually started the company. I think he, had been reading research papers on and off and implementing all kinds of different proof systems, and at some point built a Stark-based system that we were confident could do recursion, in a very sub-second kind of time frame. And the possibilities there, we just started chewing on that idea, over and over again. And personally, the thing that really caught my attention and really drove me to want to start the company is just the possibilities that at the intersection in ZK and identity, and the difference between somebody needing to know everything about you and nothing about you, and being able to explore that space in between is really the thing that got me going. But the company really got started when we realized we could do, we could actually make a general purpose ZKVM and have it do practical things.
What year? I want to kind of track down now everyone's year of entry. So we've been talking. So Brendan's 2018, I think. ZCon 0.
Yeah. So I think,
or a little bit before, maybe, because you had already heard about the. What would you say, Brendan? What year is yours?
I don't know. Maybe like late 2017 when I started reading papers. But,
okay.
But it was like a pretty slow.
Okay, Brian, what about you? When did you join?
It would have been 3 years ago, basically. I think that's when Jeremy really started, talking to me about this incessantly, and I really started spending a lot of my time exploring, the papers, the research, and the possibilities.
And Nico,
but I think he started like 7 years ago.
Okay, so he was already in it. Okay.
Yeah.
But Nico, what about you? So we were confused. What's the year?
Yeah. So it's a bit of a two-part journey. Like I had the intro to ZK in say late 2019, early 2020.
Okay.
But at the time I was like, I don't want to do anything that remotely touches a blockchain ever.
Okay. You're anti.
Yeah. And then it took until like late 2021 for me to be like, okay, fine. There's nowhere else that wants to use ZK right now. So I'm going to have to get into this Web3 space.
So I think we kind of touched on this, Brendan, but I want to throw us back to 5 years ago and what was there and what was possible. Like this idea of you kind of getting interested in it, what was actually around for you to learn what this thing was, and how did you onboard yourself? Like you started a company, but like, did you start the company and then you learned all the stuff by trying to implement it, or had you already researched?
Yeah.
What was there?
I thought so. Like the papers that were available were like Groth 16. There were a lot of explainers that were sort of at a high level, but I think I remember the Marlin paper being like a very like nice exposition, and then Planck, Planck was before, but I read it after. But yeah, I mean, like there wasn't like a lot of the conceptual frameworks that people use to understand things now, with like traces and columns and just like a very sort of like simplified and to the point explanation that doesn't have like a lot of cruft. Like that didn't really exist, and so I think it was like a little bit harder to parse and to like develop a mental model for how everything worked.
Cool. I have no background anymore. This is a great panel, guys. This is like, anyway, sorry. Okay, going back then to what I hear from what you were saying though is you had to do stuff like you had to go into those papers. There was no introduction to ZK, like there was no hand-holding for you.
Yeah. I mean, Daniel Lubrov might say that he did a lot of the hand-holding
for you. Okay.
Yeah, I mean, there wasn't really a lot that was available, and yeah, I think just like very early on in like 2017, 2018, even understanding like conceptually what people were referring to when they talked about an arithmetic circuit and gadgets and like the stuff that where it was just kind of foreign to me and wasn't like the way that I would sort of think about it and describe it. I think that was that was hard.
I feel like we are seeing a bit of a trend with Brian and Brendan here, where it's like someone you work closely with who's a little further ahead and kind of bringing you on. Do you know how they started? Like, do you have some sense for like how those, first generation? Because the reason I'm talking about this in general is like, we're here at the ZK Hack. We're all about education. We're going to have a job fair after this where people are going to, we're going to get to meet folks who are trying to get into the space. And I think there's a lot more resources now, but yeah, I have been curious how those first generation folks did it, because those papers were not easy. Like you mentioned Marlin as like a paper that starts to become a little bit more accessible, but that's 2019. So yeah.
Yeah, I mean, like Groth 16 is like a difficult, like it's not like there's not really like a lot of conceptual separation between the core of the protocol and like optimizations that make it more efficient. And so I like, for me, it was just difficult to read and to follow. And so, I think, I don't want to speak for Daniel, but I think he had good luck with some of the like other schemes that weren't immediately practical, like kind of like the ZK Boo lineage, and so I think that like taking a really wide survey of the literature and the work was really helpful for him.
Yeah, I think Jeremy just reads math papers to go to bed. It's like way to calm down. And then also I think similar to what Brendan's talking about, Jeremy started like building the simplest things that I think he could sort of find, and then ramp his understanding up over the course of like 6 different proof systems, before we got to the first sort of prototype of RISC Zero.
Yeah,
There's
Nico, I want to hear. I want to hear.
There's a comment in the chat that I do want to echo, and it brings into like how I got into it, is that snarks are a very specific like construction of ZK, and they're a very like complex one. But you have much simpler ZK protocols that date back to the late 80s, 90s. And so that's sort of what we were taught in university, actually. So
is it this comment? Hold on, is it this one?
Yeah, ZK is not new. Schnorr is a ZK identification scheme. And so Schnorr signatures are actually, they come from an interactive ZK protocol. And these are pretty easy to understand and reason with. And I can, at least for me, that was the segue into the more complicated ZK protocols.
For kind of going kind of forward now, like, so you founded companies or you work in groups which are doing cutting edge research. When we think of the audience here today, like, what would you say today people should be trying to do? Like, what do you even look for if you're meeting someone to collaborate with or potentially hire? Like, what kind of background, like, should they have, like, at what stage do you think they need to be to work in the space is kind of the question. Because I want to say something else that I've heard a lot is that the easy stuff, the sort of general concepts, high level, is really accessible and there's lots of material. And then there's the papers and there's all of this space in between those two things that I think people get kind of lost in. But what would you need someone to have accomplished or gone through to work with them? Or do you think they should do to get to that stage to be able to start building stuff?
I mean, at least from our perspective, it really depends on what kind of role you're looking for. If you're going to be a circuit designer and really working on the core proof system, building accelerators, working on the sort of compiler framework, then we're really looking for people that have, extensive compiler experience there's ZK is old enough now that it's not, that hard to find people that have a lot of hands-on experience using different proof systems. We're a very engineering focused company. So I think it's a little less about research for us and a little more about demonstrated engineering capabilities. But, for the rest of the company, we're all working in applied ZK and understanding the concepts and really what you can do with ZK, what you can't do with ZK, and everything in between. I guess that's critically important. And I think participating in any of these kind of basic ZK hack type events, anywhere from the really complex puzzles to some of these, initial educational events. I think it's all useful. So it really depends, on exactly what you want to do.
I wonder, do you also look for like are there like product people yet in ZK? Is that sort of a subfield, or is it still too deep in the like that you need to be too technically aware of what's possible before you can start kind of doing more like user product development?
I think it's the field's matured enough, and I mean maybe other people have different takes, that you can become a successful product person in ZK without an insanely deep technical set of knowledge. But you do really need to stay on top of all the advances and understand the characteristics of different proof systems and how they're going to actually be applicable to problems in real life. So,
Brendan, what about you in terms of like what you look for when you collaborate, et cetera? And also there's some good questions in the chat. I love that you guys are posting that. I will be bringing those up in a second. So keep doing that.
So for us, we hire for both research and engineering roles. There's a pretty wide variety in engineering roles. Like we have people that just focus on hardware optimization, and they don't really need to know like exactly how the IOP works. They really just need to like make field arithmetic really, really fast. But on the research side, we've actually had really good luck with people that have a high level of mathematical maturity, even if they don't have a lot of direct ZK experience. So I think having a math PhD and being able to code is like a really big advantage. And so we've hired people that have like no idea what a zero knowledge proof is, but they have been able to contribute pretty immediately. And so I think that like the things that we look for are either like a high degree of mathematical maturity and like the ability to code, even if you're not like necessarily at the level of like producing production ready code, or like a demonstrated track record of contributing to open source software that we've created. So we have hired people that have just made open source contributions to Plonky 2 and Plonky 3, and it's just incredibly obvious that they're very, very good and that they would be a great addition to our team. And so it's kind of we're also a small team, and so we have like kind of the luxury of being able to be selective.
Yeah, I would echo that. Also, in terms of the sort of general math background, we have several people on the sort of proof system team that really didn't have a ZK background at all, but were very strong mathematicians, and they, fish in water, I guess.
They pick it up fast. What about on the geometry side, like on that, when you guys are thinking about collaborating, or because you're doing like, you're not as much on the implementation side. There's not as much like, how do people contribute to your research? It's not like,
So, I mean, it really depends for us, and we are doing some more implementation-y things these days. So it depends, but I do see, as Brendan was saying, sort of two tracks, like the research track, we're going to look for someone who's very mathematically minded, who probably has a bit of experience with cryptography or has a lot of experience with math. Like, if you don't have any cryptography, you have to sort of balance it out with, are you fast enough to get it once I explain it to you? Maybe it's okay. So that's sort of the research track, and the engineering track, same thing. You want someone who knows how to deal with software. Not saying knows how to deal with cryptography, because the tooling these days is sort of developed enough that they will catch up. It's not like we're asking them to write these proof systems from scratch. I think there's more and more space for entry-level jobs that don't require a PhD, right? Like, that's cool. Or at least that used to be the requirements I saw when I was looking for jobs in the space 2.5 years ago. It's like, wow, why does everyone have a PhD in cryptography? Like, how does everyone have 3 or 4 years of CIRCOM experience? How old is this language?
Yeah. Okay, we had a question. It's sort of related. I think also people have taken a stab at answering it, but I'll bring it up. Do you feel that ZK application development is more akin to data science skill set, right? To a data science skill set than an application developer skill set? Yeah, that's interesting. Data science, like, is it?
I don't think of it that way personally. I think of it more as, traditional application development with this sort of added twist that you need to understand what it is that ZK is doing and how it actually interacts, with the application that you're trying to build. And I think we've seen, throughout all the hackathons we've been part of, we've seen people kind of misunderstand what ZK actually does and then build something that they think does one thing, but actually doesn't actually do the thing. So there's this level of applied ZK cryptography that I think is the main skill that's needed for operating effectively in building ZK products.
Just by the way, Nico, I think it's your background. It sounds like someone's doing dishes or something. Cheers. Okay. Let's see. So here's someone wrote, so circuit construction is more CS-ish and the circuit evaluation and optimization more math-ish. I think this is in relation to, actually that might be in relation to a comment in here. Maybe it's a little bit out of context.
Yeah, but I do like the question, and you do see people in this space that have more of a CS background and others who have more of a math background. It's interesting to see how they think differently and how they bring different ideas. So I guess both are welcome in either side of circuit construction or circuit evaluation. I know, like, for sure, having an EE background, and I see there's another comment about logic gates, CPU design, and assembly language. You don't need it to work in the space, but it will help you reason about ZK VMs. It will help you reason about what's a ZK circuit and how do I build my circuit.
What do you think is missing in our space? Product people?
Product people?
Sorry. Maybe I was mobile.
Maybe, well, yeah, I don't think people are going to be, right now we're focusing a lot on running from like strong hardware, servers or like big machines, running from a browser. But I don't see a lot of people developing ZK provers for mobile phones. And I think that's probably where we're going to spend most of our time proving things, or for the small things, not for proving like big computation, like ZK VM style, but small identity things. I think that's going to happen on the phone. So
are you saying though you'd need like mobile, like app developers to start locking into the underlying systems?
Yeah, or for this community to start attracting these people, or to start looking into how long does it take to prove something on a phone?
Yeah, I agree with that. Certainly, as soon as you start going mobile, there's such a huge variety of chipsets, and it requires like a much bigger lab, and it's like pretty capital intensive. So maybe it's going to be a community effort to figure all of this out. I guess it's a bit easier with the set of phones that are out there now, but certainly it seems like there's a lot of potential there that's unrealized. Yeah, and I think critically important. I think people are just declaring the end of ID as we know it because of all the deep fake heists that have gone on, and realistically, your smartphone and any modern ID is enough to privately prove that you are who you say you are. So.
Brandon, what do you think? Well, what's missing?
What roles are missing? Faster is our philosophy at Polygon Zero. But yeah, I mean, I think client-side proving and mobile proving is really interesting. I also think like privacy that's actually usable and that is like more accessible to people on blockchains or applications that they currently use. I think that would be helpful.
Yeah, I think. Oh, sorry.
No, go ahead.
I was just saying the only thing I would add, from our perspective is, and this is something we're very much working on, is making it even easier for more applications to run in ZK. So right now you still have to kind of modify, even with RISC Zero, you still have to kind of modify your applications a little bit, but it's still not quite like just running something on Linux. And I think once we get there, we're gonna have a lot more utility.
Hmm.
I also,
I would
Go ahead.
ask you to pull that one up.
Yeah, but go ahead, Brendan. I'll ask this after.
I was just gonna say, I think that we really just need like one really good dog coin to ensure like funding and R&D progress for the entire space. So if someone's working on that, that's also important work.
Okay, I just pulled up another question from the chat. Are there other security jobs in ZK? Something for people coming from areas such as vulnerability research, threat detection, or response and dev?
Yeah.
I'm going to say, looking at our burn from the last 3 quarters or so, I'm going to say yes. There's at least a lot of money there.
So this is like the auditors, or what is this?
Exactly.
Yeah, exactly.
It's a good time. I mean, oh, sorry. Well, if you think about all the startups that have been funded in this space and that are starting to build, by now they're starting to push out their products or push out like first versions of them. So it's sort of a good time to start looking at security and like auditing all these projects. So yes, if you have experience with vulnerability research, threat detection, you will probably find work in the coming months in ZK.
Yeah. Do you think there needs to be more auditors, more auditing firms? Because right now there's not that many that would be able to say that they have the expertise needed to really look at these systems, I feel.
Yeah, I think there are more firms that are, I would say, more talented than I sort of assumed going into the search process, and we try to rotate through all of them, I guess. But yeah, I think there's going to be a clear need for more.
Someone asked about, when you're talking about deep math knowledge, what kind of knowledge do you mean? Does it matter? Could it be any of these things, or is there specific things that the PhD should have, like the PhD in math should have focused on to be really quick to onboard here?
Some things you can't do without, right? So like probabilities, you can't do without, because that is sort of how we reason about our security arguments. Elliptic curve, lattices, isogenies, these are sort of plug and play things. Like some protocols will use them, others won't. So you're going to get to choose through your journey into the ZK math whether or not you want to go into these areas. So it's just a matter of like, can you pick these things up quickly? And usually the more math you've seen, the more likely it is that you will be able to.
What is a good learning path for a protocol engineer to get into ZK? I wonder if, Brendan, if you have an idea here. Because this is also sort of a group that I feel we see a lot of. It's folks who've worked on blockchains, building core infrastructure for years. They're very used to distributed systems, networking, like all the things that go into that. But yeah, what would be a good kind of route into the ZK world? I guess like maybe working on a ZK L1 that also has those things, maybe?
Yeah, I mean, I think that the transition from working on that to, building circuits, like I don't think that that's like a huge lift. And so I think that there are resources and tutorials that kind of onboard people into like the programming model of ZK. So you can black box, how the underlying proving system works, but you can understand fairly quickly like how circuits work, what the programming model is, what sort of like what it means to like program with non-deterministic advice and only use field elements. And so I think that that's like an accessible path for people with that background.
There's another question about formal verification. This is actually this comes up quite often, and I've heard from like the FHE side more than the ZK side. Is there an overlap in formal verification and ZK end user apps? Oh, sorry, no, I thought he said FHE. No, this is something else. My bad. Formal verification and ZK end user apps. Well,
I mean, I think it's interesting because, ZK fundamentally lets you prove that a program was run correctly, but it doesn't say anything about whether the program that you're running does what you claim it does, right? So there's this idea that, you know, if you're, especially if you're writing in a higher level language and using some kind of ZKVM, it's, you know, if you're really trying to build a secure system using ZK, then, you know, maybe you do want a bit more certainty about what the program that you've actually written does. So you can, especially if you're going to communicate that to other people without revealing the source code, which is one of the interesting things you could do with ZK. So I think there is a lot of like overlap or sort of synergy between formal verification and ZK, but you know, I don't know how directly related they are. So
and aren't there people doing formal verification of ZK systems as well? So like you could use the technique together with it, but I don't know if it's exactly the same thing. I found the question I meant to put. Apologies. This was the one I was looking for. I don't know what it's referencing exactly, but is it because it's still early that few companies are looking to combine ZK and FHE? And I don't know if this person is saying that there are a lot of companies trying to do it or if there are not a lot of companies to do it, but let's talk ZK, FHE, and the combination. Is anyone here working on that?
On this panel?
Yeah.
Technically, you could run any FHE encryption on RISC Zero, right? And prove it with RISC Zero. Like that's the beauty of a general purpose VM. Same with, mined in VM, for example, to keep.
It's very slow though.
One example
it's
from
very
each,
slow.
It's very slow. And that's sort of the answer that I was going to get at, is that ZK's early days, we're only now starting to see like practical provers. FHE is still super early days as well. It's very slow if you want to like compute anything meaningful. So combining both, you can imagine, is incredibly slow. So yeah, the answer is it is still very early and it is still very slow.
But I do think, you know, to Brendan's point earlier about, you know, Plonky's mission and the advances we're seeing, I do think it's going to become just, you know, it's going to be a good couple of years, I think, for the overlap.
Do you still, like, kind of going back to the earlier part of this conversation where it was like what you read or got into to onboard yourself, how do you now approach like research today? Are you still looking out for the latest of all? Have you picked certain tracks that you're kind of focused in on? And where do you find this research? Like, how are you still feeding the learning? And I realize it might not be you on the team, maybe it's someone else, but yeah, how is it? How are you doing it?
ZK Mesh, obviously.
ZK Mesh, of course.
No, but seriously, that's mostly how I stay up to date.
Really?
Personally, yeah.
Oh, cool.
But also, you know,
we look at ePrint. We're mostly looking at ePrint for that. Okay.
But you know, we also have amazing like you know, partners that help us stay at the forefront. And then, you know, I think if you're Jeremy or any of these other kind of like people who are really in it, then, you know, everybody has their own, I think, preferred discovery sources, I guess.
Brendan, what about you? Have you focused in now on a particular track and you're tracking that? Or are you still like getting a lot of input in terms of research? And where do you get it from?
So I think, like, in terms of a particular track, do you mean like schemes that rely on elliptic curves versus small fields?
Small fields is kind of, yeah.
I think I'm opinionated but open. I sort of have high conviction that the small field approach is sort of the best one for what we're doing and our use case and our requirements. And like, I just am very convinced that that will continue to be the case. But if it's not, then, you know, we would obviously pursue the like, you know, most efficient and highest performance method. But yeah, I mean, in terms of where we get like where we learn about new research directions, I mean, not to like flex, but some of it is like we come up with it and we work on it. Like we invest in research and R&D, and like we just think that it's good for the space, it's good for us, and that's like something that we think is really valuable to do. But also, I think just just being around like really talented people working in other teams, like the Olvatana guys, Jim and Ben.
Yeah.
I've known Jim for a long time, and it's like I think it's like obvious when people are super talented and working in the space, and just I think that often yields really good results.
That was kind of what I was wondering, was like, how do you, like, we did this episode together where we interviewed the folks from Olvatana, and it was like, it's not your project, but I was kind of like, how did you know about it? Was it, you saw it in a chat? Was it your team was excited? Had they reached out before for some thoughts from you? Like, yeah. If you are finding these resources outside of the company, where do you actually find them?
Yeah, I mean, in that particular case, Jim has been sort of like the white whale of someone that we've wanted to hire for like many years, and he just turned us down, which I think was a good decision for him, and he's like in a great spot. But so that's a special case. But I think just like, I don't know, I think for us, we want to be competitive in the space in a positive way. Like we want to like draw motivation from what other people are doing. But I think like for the most part, we want to just maintain good relationships with people and just work in ways like we're working on something with Starkware that's really exciting, and we think that will yield good results. And so I think obviously there's a sense in which proving systems and ZK R&D kind of has like a dual purpose. It's obviously for improving the product and pushing the space forward, but it also sort of functions as technical marketing. And so I think that there's a sense in which people want to be really territorial and provincial about the research that they do. And I think as a space, like we could do better in kind of getting over that and working across teams. And that's something that we've just been trying to do.
I have a question here going back to the security researcher. So how would you best position yourself as a security researcher for ZK audits? I feel like there is a path here. But how would someone do it? Like, is it start contributing, is it sort of be a white hat, find a problem? Would that be like a good starting point?
Maybe that's definitely yes, hard. But that's a very hard one, right? Yeah. It's sort of, all right, I'm going to stare at code bases for stuff that I don't necessarily know and hope to find something wrong with it, which is a very big ask, Like, yeah, sure, man, go do that, and you'll find a job. But that is one way to do it. Otherwise, I'm not sure. I guess ZK Hack had that intention of getting you into this reasoning of like looking at these protocols and what's wrong with them and how do we fix them. One good way to do it is take an implementation of a protocol and the actual paper and sort of go back and forth between them, see what the differences are. That's at least where I have found discrepancies, and you get to learn about the security of these systems in that way.
That's interesting. I mean, and thanks for the shout out to the puzzle hackers who just, we just are wrapping up our puzzle 3, but I know that there's also been like ZK CTFs floating around. Did those also help potentially? Maybe.
I don't know. I haven't looked at them too much, but maybe
if anyone here has done them. Yeah. That's cool. There was a question in here about how small is a small field. I don't know if you want to weigh in on that, Brendan.
I mean, I think the chat has
kind of answered.
Given answers. I guess we can. So answers in the chat are 32 or 64 bits as opposed to the snark fields of 256. That's true, but we can also go down to just 2, right? Then this is like the binary field work that we were mentioning just now, the Jim Posen and Ben Diamond work.
I don't know if we're going to be able to answer this one, but is there any theoretical upper bound on the cost of the prover and verifier in zero knowledge proof systems?
Yeah.
Maybe.
So the prover, we know for sure
a lower
can't
bound?
be. Oh.
Okay. Is it upper bound?
Yeah, I think lower bound.
Very slow.
I guess, upper bound on how good can it perform, right? But no, the answer is like prover, we know that you can't prove something quicker than it is to actually run it. Right, so your prover will at least be some constant factor bigger than running the computation natively. Verifiers, we know we can go down to constant time verifiers. Proof size, we know that Groth16 is the smallest possible proof. Verifier time, I'm not sure exactly. Yeah.
Keep the questions
and again,
coming,
this
though.
is sort
We
of
really like it.
asymptotics.
Cool.
These aren't concrete numbers, right? What I just said are upper or lower bounds in terms of asymptotics. Important.
Okay. We talked a little bit about the small fields as a trend. What are other trends today in research that you're paying attention to? Things that you see, like, I mean, I think in 2019, it was this plonkish arithmetization and the breaking up of the snark into multiple pieces that then had the lookup tables and the folding schemes. So I mean, it's too early in the year to say what this year's trends are, but yeah, are you seeing anything that you're paying attention to in that realm?
Should I?
Go for it.
So I think, 2024's hottest trend will be
Small fields.
so not even small fields, but like there are small field, like there are different 32-bit fields, and so there are some that have really, really fast reductions and are really efficient in CPUs and GPUs, and so. But they have drawbacks in that some of them are like less friendly for the types of things that we need to do with zero knowledge proof systems. And so figuring out ways around those limitations so that we can get the really hardware friendly fields without paying a penalty when we're actually generating a proof is something that we're focused on. I think the binary field work from Jim and Ben is really interesting. And I'm trying to think if there's.
And I think also being able to glue multiple circuits together more flexibly without, necessarily blowing up the layout of your circuit. I know, like, Lydia's working on that. We're working on that. Lots of people are working on being able to enable teams to add more accelerators to ZKVMs is certainly something that I think is going to be a trend.
Nico, are you seeing anything on your side?
On the research side or sort of engineering?
It could be anything that you're like seeing people starting to pick at, trying to solve.
Definitely research. The two main directions were getting into smaller and smaller fields. That's one thing. And the other one is moving from this sort of univariate polynomial IOP that we have been looking at since 2019 to more of like the multilinear stuff. And part of the reason for that is because the focus had been we want small proofs and quick verifiers so that a blockchain can verify a proof. And now we're moving to, well, we want fast provers and I don't really care who verifies. So I'm okay with bigger proofs. So that's at least a research direction I've seen a lot. Engineering-wise, I'm not entirely sure. A lot of people mention, wrapping a proof system into another one. And I think we're still at a stage where it's more of we know that it's a great idea, but there isn't like one definitive code base that does it perfectly. So maybe, I don't know if that's a trend or more like, the slow climb and we're towards the end of that slow climb. I'm not sure.
There's
definitely a lot of teams building infrastructure for building VMs. So it'll be interesting to see, if the set of VMs out there starts to really increase.
This is a little follow-up to your question, Nico. Is only multilinear interesting? Why not multivariable in general?
So we have this protocol called the sumcheck protocol in multivariate land, which is super efficient, and that's why we get these nice linear time provers. But at every step of that protocol, you pay a cost that is proportional to the degree in that variable. So if you have a multilinear polynomial, the degree in the variable at every step is as small as possible. So you're sort of saving a lot there. But yes, the GKR protocol uses multivariate polynomials, so higher degrees.
Is like kind of on that. So the sum check work, is that a thread? Is that what you're saying? Like, is that
yeah,
kind
that's
of
sort of
in
what
the
I'm
same
referring
category?
to with
Okay.
this. Yeah. With the trend of we're looking for faster provers and we're happy to sacrifice a bit on the proof size or the verifier time.
On the, like, when we talk about like the Fry and the KZG and the sort of bulletproofy stuff, like, is there any new work in that particular spot? Or do people just go, Fry is as good as it's going to be, KZG's is like, does anyone try to make those different? They seem just like this foundational thing that people build on, but yeah.
Yeah. So we're working on something that I think like arguably falls into that category, but like breakdown and tensor PCS based schemes also are an attempt to like come up with more performant or faster with respect to proving time, maybe not with respect to verifier time, polynomial commitment schemes.
Cool. There was a question on this. When will we see public ZK audit contests? Haven't at least noticed any. Wasn't there some, like, there's bug bounties and stuff for ZK VMs, but yeah, do you guys know about any of these?
I think
we're starting a bug bounty program. That's about it.
Okay. Nico, you were about to say something.
Yeah, no, I was saying I think Alio has a bug bounty program. But correct me if I'm wrong. This is distant memories.
We have a bug bounty program. I think ZK Sync just ran a competition.
Yeah.
And so, yeah.
But I guess these are always like the audits. I mean, in this case, they are primarily on, I guess, roll-ups mostly, I know RISC Zero isn't a roll-up, but could have a roll-up on it somehow.
We've had the core proof system audited, and then also, we have a GRA16 verifier that takes the sort of snark to snark and lets you post it on Ethereum more cheaply. That's definitely been audited. So, I mean, really the audits, at least from our perspective, span the entire software stack top to bottom.
But no public. You wouldn't put this out. Because that's the thing, is bounties to me are always kind of like bounties. Maybe the ZK Sync one was different, but I feel like usually what I see are like bounties are for very specific, smaller pieces. This almost sounds like some big, I don't know if there are these audit contests in other fields. I don't know if you're familiar with them, but. No. Okay. Let's talk about, we don't have too much time left, but what is this is actually a question somewhere in here, but I also had it in my notes, which was about the use cases. And maybe this one. On the application level, is there anything that excites you right now? And what I wrote was, what is the most exciting ZK application you have heard about?
I think Penumbra is really cool. Yeah, I think like privacy preserving AMMs are really cool.
Nice.
Okay, so, my answer is kind of a two-part answer, I guess. The boring answer is like TLS notary type systems combined with general purpose ZK. Like somebody just did a proof of accreditation, so you can actually like provably download your tax returns from the IRS privately and then suck out the gross income lines and actually create a proof that you're an accredited investor completely privately.
Oh man, so, that would be so good.
It exists. It's like there's a GitHub repo for it. They used RISC Zero and ZK Pass.
Oh, wow.
But that thread, I think there's so many amazing things you can do with that, especially in light of the kind of deep fake take like mafia raids on corporations and stuff, I think this is going to be like really important. And I think, you know, it's also going to like attested sensors and like multimodal like verification to just increase the probability that you're actually dealing with the person that you the other side of your communication like claims to be representing. I think is going to be a really interesting set of like, there's a lot of technology that needs to be built there.
Cool. Nico?
I really like this sort of stuff that plugs into existing infrastructure and brings it to like to privacy land. So things like ZK email, where you can prove, you know, some email came from a specific domain and this is what's inside of it. Or things like ZK login, I think that Sui has been putting out. So plugging in with OpenID and proving that you've logged into your Google account. Those are use cases that I like because they then feel like they're unlocking applications. I don't know if they are. I hope people will come up with good ideas of where to use this. But they really feel like sort of the next step of like, okay, we have this tech that protects private data. We now can log in privately to our accounts. What can we do next?
I mean, I know at the beginning of 2023, I'd highlighted sort of ZK ID, but in the Sysmo model, this like what I was calling like merit-based identity, where it's like something you've done on chain, you're able to mint these badges that sort of testify that like, yeah, you've done that thing, or attest to the fact that you've done that thing. But there's no connection between the account that did the action and where you hold the badge. That project is sadly defunct. So they're no longer going to be running. They're not going to be building. I still think there's so much cool stuff in the idea that they had. And I actually think there's so much potential in that idea for other teams to run with. They've built a lot of the sort of the foundation of the experiments. They've had a lot of the thoughts. They've published it. It's open source. I know all of that. So I hope somebody does something there. And then I think the ZK email opens up, that connection to the Web2 world. And I've heard, I mean, I actually, little sneak peek, there will be an episode coming out with them soon because we've talked about them a lot on the show, but I felt in talking with them, there's so many ways, sort of nuanced ways that you could actually use this. The basis, it's cool in what it does, but we've now, I think at hackathons and stuff, you start to see people using it and trying to experiment in all these different ways. And it reminds me a little bit of Sysmo. It's different. I'd love to see a combined one with attested sensors and some sort of that still also has to be there, but I'm kind of on the lookout. I mean, I think this is going to be the year of experiments of this nature. And then I hope that by the end of the year, we have almost like it gels together in some sort of product that emerges, like something you can actually imagine using. And who knows, maybe it'll be like some social component as well. That's what I'm excited about. Okay, when it comes to these trends, and this is sort of, I already asked this question a little bit, but do you think, this is sort of advice to people who want to get on top of the trends and want to be right up to the edge, maybe want to work with you. Yeah, what's the advice? I know we've already mentioned ZK Mesh. You can read about ZK Mesh, but putting yourself in the position of folks who are they want to enter the space, but they don't they're going to do the background research, but they want to put themselves sort of on the cutting edge. What do they do?
I mean, I think it's build an interesting application and actually use these kinds of systems. Build something on RISC Zero, build something on Plonky 3 or Plonky 2, or actually, show up, build something interesting and promote it. And I think those are some of the I think best connections we've made in the space.
Cool.
Yeah, I'd echo that. For people that want to get involved on sort of the research or the applied cryptography side, I think just implementing a simple proof scheme or making open source contributions, those are things that get recognized and are a good way to actually test your understanding, because you can sort of move through a tutorial or read a paper, but when you actually have to implement, then it's kind of...
That's the real deal.
Yeah. And without even building a full application, so echoing what Brian was saying, if you find a specific DSL and you find that there are some, I don't know, interesting crypto primitives that aren't implemented in it, try to see if you can write it, right? Like some people have had great success writing sort of RSA verifiers in Circom, or I don't know, people have been writing Noir, and doing these things might not be useful right now. It might get picked up by other projects later, but often at least it puts you on the map and people will know, oh yeah, this is the person who wrote, I don't know, some encryption scheme in Noir. We should probably chat with them.
Perfect. I think that's a great moment to wrap up our panel. I want to say thank you to all of you for joining. I'm so happy we had these wonderful panelists to go through this topic of like what it's really like to work in ZK. Brian, I'm so glad you made it.
Me too. Thanks for having me.
Yeah. All right. So thanks to all of you. And I guess that's a wrap.